Hello friends, welcome to Easy Learn. In this video of Standard 9 Science and Technology, we are going to see the question and answers of Chapter 1 Laws of Motion. If you like this, do subscribe Easy Learn and press bell icon to get the notifications. So, let's begin. Question number 1, match the columns. Answer: negative acceleration, the velocity of the object decreases. A vehicle moving with the velocity of 10 meter per second stops after 5 seconds. Second, positive acceleration. The velocity of the object increases. A car, initially at rest, reaches a velocity of 15 km per hour in 10 seconds. Third, zero acceleration. The velocity of the object remains constant. A vehicle is moving with a velocity of 25 meter per second. Question 2. Clarify the differences. First, distance and displacement. Distance. It is the length of the actual path traveled by an object. Displacement is the minimum distance between the starting and the finishing points. Distance may be 0 or positive. Displacement can be 0, positive, or negative. Distance is a scalar quantity. Displacement is a vector quantity. The SI unit of distance is meter. SI unit of displacement is also meter. Second, uniform and non-uniform motion. First, the motion in which the object covers equal distance in equal interval of time is called uniform motion. The motion in which an object does not cover an equal distance in equal intervals of time is called non-uniform motion. Speed remains constant at any interval of time in uniform motion, and in non-uniform motion the speed is not constant. The graph of a uniform motion is a straight line passing through origin, and the graph of non-uniform motion is not a straight line. Complete the table. The table is given in the first. U is given, A is given, T is given, and the formula is V is equal to U plus AT. So first, V is equal to U plus AT. Therefore, V is equal to 2 plus 4 into 3. V is equal to 2 plus 12. Therefore, V is equal to 14 meter per second. So the first answer is 14. Now in the second question, they have given A, T and V, and we have to find U. So again, using the same formula, let's substitute the values. 20 is equal to U plus 5 into 2. That is 20 is equal to U plus 10. Now we want U. So U is equal to 20 minus 10. Therefore U is equal to 10 meter per second. So that is the second question. Table 2. Now in this case, it is Newton's second equation. That is S is equal to ut plus half at square. Now in the first one, U is given, A is given, T is given. We have to find S, that is displacement. So S is equal to ut plus half at square. Substitute all the values, you get 92 is equal to 7 into 4 plus half A into 4 square. So we are solving the second sum. So 92 is equal to 28 plus 16 upon A. 92 is equal to 28 plus 16 divided by 2 is 8A. Therefore, 8A is equal to 92 minus 28. 8A is equal to 64. Therefore, A is equal to 8 meter per second square. Now the first sum. S is equal to ut plus half at square. S is equal to 5 into 3 plus half into 12 into 3 square. That is 15 plus 6 into 9, which is equal to S is equal to 15 plus 54, which is equal to S is equal to 69. Therefore, 69 meters is the displacement. Table 3. Third equation. V square is equal to U square plus 2AS. So again, the first one. V square is equal to U square plus 2AS. 8 square is equal to 4 square plus 2 into 3 into S. 8 square is 64, 4 square is 16, plus 6 into s. Therefore, 6x is equal to 64 minus 16. Therefore, 6s is equal to 48. S is equal to 8 meters. So, in the first question, the value of s is 8. Second, v square is equal to u square plus 2as. 10 square is equal to u square plus 2 into 5 into 8.4, which is equal to 100 is equal to u square plus 84. Therefore, u square is equal to 100 minus 84. U square is equal to 16. Now taking square roots, we get u is equal to 4 meter. Complete the sentences and explain them. A. The minimum distance between the start and the finish points of the motion of an object is called the displacement of the object. Explanation. In the figure, A is the starting point and C is the finishing point. In displacement, the actual path is not followed, but the minimum distance from A to C is considered. B. Deceleration is negative acceleration. Explanation. If the velocity of the body decreases with time, the motion and the acceleration also decreases. This is called deceleration. C. When an object is in uniform circular motion, its velocity changes at every point. Explanation. Uniform circular motion is occurred in circular path. Therefore, its direction changes and results into change in displacement. Velocity is the ratio of displacement and time. So, when an object is in uniform circular motion, its velocity changes at every point. D. During collision, the momentum remains constant. Example. According to the law of conservation of momentum, the momentum gets divided between the colliding objects. As a result, during collision of objects, momentum remains constant. E. The working of a rocket depends upon Newton's third law of motion. Explanation. According to Newton's third law, every action force has an equal and opposite reaction force, which acts simultaneously. The rocket works on the same principle of Newton's third law. Give scientific reasons. First, when an object falls freely to the ground, its acceleration is uniform. Answer. The gravitational pull of the earth acts on the falling object. While falling down, it moves in a straight line and the velocity changes by uniform rate. Hence, when an object falls freely to the ground, its acceleration is uniform. B. Even though the magnitude of action force and reaction force are equal and their directions are opposite, their effects do not get cancelled. Answer. When two forces acting on an object are equal in magnitude and opposite in direction, they cancel each other. But action and reaction forces act on different objects. Therefore, they do not act on the same object. C. It is easier to stop a tennis ball as compared to a cricket ball when both are traveling with the same velocity. Answer. The mass of a tennis ball is less than that of a cricket ball, and momentum is equal to m into v. So, the momentum of the tennis ball is less than that of the cricket ball. Therefore, it is easier to stop a tennis ball as compared to a cricket ball. D. The velocity of an object at rest is considered to be uniform. Answer. The velocity of an object is the ratio of the displacement and the time. The object which is at rest has zero displacement. Therefore, it has 0 meter per second velocity. This velocity remains constant, so the velocity of an object at rest is considered to be uniform. Solve the following. An object moves 18 meters in the first 3 seconds, 22 meters in the next 3 seconds, and 14 meters in the last 3 seconds. What is the average speed? Answer. Total distance covered is equal to 18 meters plus 22 meters plus 54 meters. Total time taken is equal to 3 seconds plus 3 seconds plus 3 seconds. Therefore, average speed is equal to total distance upon total time taken. So total distance average speed is equal to 54 upon 9, which is equal to 6 meter per second. Therefore average speed is 6 meter per second. Second, an object of mass 16 kg is moving with an acceleration of 3 meter per second square. Calculate the applied force. This is the first part of the question. If the same force is applied on an object of mass 24 kg, how much will be the acceleration? So there are two parts in this question. Let us start with the first part. Answer: given mass m1 is equal to 16 kg, acceleration a is equal to 3 meter per second square, and we have to find force. The formula for force is equal to mass into acceleration. Solution: force is equal to mass into acceleration. Therefore, force is equal to 16 into 3. Therefore, force is equal to 48 kg. Now, this is the first. Second part of the question is the same force is applied. It means that force F1 is equal to F2. So, second, mass is given as M2, 24 kg. Force F2 is 48 kilograms because F1 is equal to F2. To find acceleration A, formula: force is equal to mass into acceleration. That is 48 is equal to 24 into A. Therefore, A is equal to 48 upon 24. Therefore, acceleration is equal to 2 meter per second square. C. A bullet having a mass of 10 gram and moving with a speed of 1.5 meter per second penetrates a thick wooden plank of mass 90 gram. The plank was initially at rest. The bullet gets embedded in the plank and both move together. Determine their velocity. So here you have a bullet and a plank. So the mass of the bullet M1 is given as 10 grams. When we convert into kilograms, we get it as 0.01 kilogram. And the initial velocity is 1.5 meter per second, that is u1. For plank, M2 is 90 grams, which is equal to 0.09 kilograms, and the initial velocity was 0 meter per second. We have to find their velocity. According to law of conservation of momentum, total initial momentum is equal to total final momentum. That is m1 u1 plus m2 u2 is equal to m2v plus m1v. That is m1 u1 plus m2 u2 is equal to v is common in the bracket m2 plus m1. Substitute the values: 0.01 into 1.5 plus 0.09 into 0, which is equal to v into 0.01 plus 0.09. That is 0.015 plus 0 is equal to v into 0.10, which is equal to v is equal to 0.15 upon 0.10. Therefore, the velocity is 0.15 meter per second. Therefore, the velocity is equal to 0.15 meter per d. A person swims 100 meter in the first 40 seconds, 80 meters in the next 40 seconds, and 45 meters in the last 20 seconds. What is the average speed? Answer: total distance covered is equal to 100 meter plus 80 meter plus 45 meter, which is equal to 225 meters. Total time taken is equal to 40 seconds plus 40 seconds plus 20 seconds, which is equal to 100 seconds. Average speed is equal to total distance upon total time taken, which is equal to 225 divided by 100. Therefore, the average speed is 2.25 meter per second. Thank you.